Hey, ladies and gentlemen, here's the first part of the series notes. All right, suppose a section of an amphitheater can seat 18 people in the first row, and each row can seat 4 more people than the previous row. Find the number of people who could sit in the first 5 rows. All right, so I'm just going to give myself a little more space. So row 1, they say, has 18 people. So row 2 has 4 more than that. So 18 plus 4, we have 22. So row 3 has 4 more than that, so 26. Row 4 has 4 more than that, so 30. And row 5 has 4 more than that, so 34. So it doesn't ask us or how many seats row 5 has. That would be a sequence question. A series question asks us to find the number of people who can sit in the first 5 rows. So we need to add those numbers all up. So I'll give you a minute to add up 18 plus 22 plus 26 plus 30 plus 34 and find out how many people sit in the first 5 rows of the amphitheater. All right, awesome. So that is 130 people. Okay, so I have a little story for you guys. In the late 1700s, Carl Friedrich Gauss was a student in a small German schoolhouse. Gauss was a bit of a troublemaker, and the teacher was fed up. As punishment, he made Gauss sit in the corner and add up the first 100 integers, with the thought of this being a very lengthy and tedious task. Gauss finished within seconds. All right, so how did he do that? Well, think about it. By the way, Gauss went on to be a very famous mathematician. He was solving solving math problems. Like, I think I read at like the age of 3, he was fixed a problem on his dad's math calculations or something. So look him up. He's a pretty cool guy. All right, so anyways, add the first 100 integers, so 1 plus 2 plus 3 plus 4, etc., and all the way up to 100. And remember, they didn't have calculators back then, so he would have to do it all in his head or out in handwritten. All right, so all the way up to 100. And he did this within seconds. And he didn't have a calculator. So let's think about this. And here, I'm not gonna make you guys like give me suggestions like I would do if we were in class. But if we take 1 plus 100, well, that gives us 101. If we take 2 plus 99, well, that gives us 101. If we take 3 plus 98, that gives us 101. Oops, that should be a 1. So Gauss knew or quickly deduced that if you add your integers from largest to smallest and add them into pairs, they add up to 101. If you get to the middle, you're going to get 50 plus 51, 101. 49 plus 52, 101. Okay, so he figured out that those pairs all add up to 101. Now, Gauss needed to know how many pairs there were. So there was 100 numbers, and if we divide that by 2, that is how many pairs there are. So 50 times 101, there were 5,050 is total if you added up those integers. So that's problem 1 for you. All right, so we have arithmetic series. These are, oh, you know what I want you to add? I'm going to go back one slide. So at the very top of your paper, I want you to write series is the sum of the terms in a sequence. So I'm just going to give you a visual of the difference between a sequence and a series. So a sequence is the list of numbers, 1, 3, 5, so on, so on. A series is the sum of it, so 1 plus 3 plus 5 plus whatever comes next, okay? Sequence is the list, series is the sum of that list. All right, so let's go ahead and look here. We have 2 formulas that we can use. S sub n stands for sum. And so the first formula we have here, we use if we know our first term and our difference, and then an n, if we have n or if we have the sum, either one of those. But we have to have at least the first term and the difference for that. This second form, you need the first term and the last term. That's what's in the parentheses here, the first and the last term. So let's go ahead and look at this example. Aiden did push-ups every day in March. He started on March 1st and increased the number of push-ups done by each day by 1. He did a total of 1,085 push-ups for the whole month. So that's not the last day, that's all of them added up. How many push-ups did Aiden do on March 1st? Well, let's think about this. We are trying to find out A sub 1. What's his first amount he did? But we have S sub n as 1,085. That's his sum of all of them. We actually know what n is. How many days are there in March? There are 31. So n equals 31. And then D, do we have the difference here? We do. He says he increased it by 1 each day. So our D is 1 then. All right, so we're going to use our first formula because we have our first term and we have our D and we actually have our sum and our n. I mean, we don't have our first term, sorry, we're solving for our first term. All right, so our sum is 1085 equals n, so 31 divided by 2, 2a sub n, sub 1, whew, okay, that's what we're going to work on solving for, plus n, so 31, minus 1, and then times our d, which is 1. Okay, looks kind of yucky, but we can tackle this, all right? Don't feel overwhelmed just because it looks gross. All right, 31 divided by 2. So if you grab your calculator, you do that in your head, you end up with 15.5. The 2a sub 1, we're going to leave that. We're not going to do anything with that yet. Now we're going to take 31 minus 1, so that gives us 30, and then times 1 still is 30. All right, again, still kind of yucky, but not as bad as the first one, and we can do that. So what I'm going to do next is distribute in my 15.5. So 1085 equals 15.5 times 2. We just did the division, so it's 31, a sub 1, plus, now don't forget to distribute that 15.5 to 30. So take a minute and multiply those, and you get 465. All right, so you want to subtract that 465 to both sides, and now we're just solving a two-step equation. So we have 620 equals 31 a sub 1. So divide both sides by 31. And we end up with a sub 1 equals 20. So 20 push-ups is how much he starts with on the first day, and then increases them by 1 for a total of 1,085 push-ups on his entire month of March. So this next problem is going to be similar. A radio station is giving away a total of $124,000 in August. That's pretty sweet. I wouldn't mind some of that. If they increase the amount given away each day by $100, how much should they give away on the first day? So let's write down what we have. S sub n. Ooh, n. August. How many days are in August? Yeah, 31. So S sub 31 is 124,000. Okay, so n is 31. And then they tell us we're increasing it by 100 each day, so D is 100. So we are working on solving a sub 1. We want to find that. So go ahead, and we're going to plug it into the same formula we did on the previous slide, so that's this one. 124,000 equals n divided by 2, so 31 divided by 2. 2a to the 1 plus, in my parentheses, n, so 31 minus 1, times d, which is 100 in this one. All right, again, looks gross, but it's doable. Start off by simplifying here and simplifying here. So 124,000. 31 divided by 2, we did that on the previous problem, is 15.5 times 2a sub 1. All right, inside here we're going to get 30, and then we're going to times it by that 100. So 30 times 100, good, 3,000. I really hope when I pause that you guys are actually typing it into your calculator. Who knows? All right, so distribute your 15.5. So 124,000 equals, all right, 15.5 times 2a sub 1. We did that on the previous problem, is 31 a sub 1. Okay, and then 15.5 times 3,000. I'll give you a minute to do that. All right. Did you get 46,500? I hope so. All right, subtract that to both sides. And we end up with 77,500 equals 31a to the a sub 1. So go ahead and divide that 77,500 by 31, and then that's going to give us our first amount that we should give out. All right, did you end up with $2,500 is the first day's giveaway? I really hope you did. All right, so after doing this note, you will be able to do on your homework, on your worksheet, you will be able to do 1 and 2. You should be able to work on 5, 6, and 7. And then 14 and 15 on the backside. Then when you watch the second half of the video, then you'll be able to work on the rest of those problems on the worksheet. Please, please, please reach out with me if you have any questions. Otherwise, I'll see you guys later.